Industrial manipulator calibration. Welcome ladies and gentlemen to this laboratory introduction about industrial manipulator calibration. The introduction video outlines the theory of industrial manipulator calibration which will be needed to successfully calibrate an industrial manipulator in the upcoming laboratory exercise. Introduction. The position of the end effector of an industrial manipulator in space is one of the most essential considerations for their successful application. In video 1, this is the position of the hand, which is important to successfully capture the objects. The position in space of an end effector of an industrial manipulator, highlighted in red, can be calculated from its kinematic model and the model parameters such as the link length, highlighted in blue. To catch a tennis racket out of the air, one probably needs to know these with values down to millimeter accuracy. But how accurately does one have to know these parameters to put a spot weld in the body in white of a passenger car, or drill a hole into the fuselage of an aeroplane? The answer is, as accurately as possible, which in commercial applications corresponds to 1/10 of micrometers. The process to find these parameters is called industrial manipulator calibration. Industrial manipulator calibration. Industrial manipulator calibration is the procedure of defining a mathematical model, modeling phase, with model parameters that are characteristic for the capabilities of the robot. Then the actual robot is measured, measurement phase, and its model parameters are identified, identification phase. The information can be used to optimize the capabilities of the robot, implementation phase. 1. The robot models and the algorithms for the parameter identification are available in the scientific literature. In the laboratory, these will be provided to you. You will have to focus on the measurement phase. In the measurement phase, the actual robot is measured to identify its kinematic parameters. This process must be done for each robot individually. This idea is visualized in Figure 2. It shows the nominal trajectory in green and the actual trajectory in red of an industrial manipulator. In the laboratory, you will use a Leica AT901 laser tracker to measure the actual trajectory of an ABB IRB 6700 industrial robot. Then you will compare the measured actual trajectory with the calculated nominal trajectory to identify the model parameters. The measurement process as presented in the laboratory represents the state of the art as utilized by robot manufacturers. More information can be found in the laboratory description. Results. The table shows the mean and maximum positioning accuracy before and after calibration for several research works. All research works cited in the table employ different industrial manipulators and measurement instruments in the measurement phase to perform calibration. It is possible to employ a wide range of methods, instruments and models. These methods have their potential strengths and weaknesses in terms of time, cost and their ease of use. In general, manipulator calibration improves the positioning accuracy from above a millimeter to less than a millimeter. Why calibration? Industrial manipulator calibration can be used to improve the positioning accuracy, which results in an optimized positioning of the end effector and consequently the manipulated object. The importance of the positioning accuracy for different applications varies from low in most pick-and-place applications to potentially lethal in telesurgical robotics applications. Video 2 shows scalpels dissecting a grape which are wielded by the Vinci surgical robot system. For you as production engineers, the difference between a calibrated and an uncalibrated robot could mean failure or success for the task at hand. But it also has further implications. Industrial manipulator calibration has further implication on the operation of industrial manipulators. Can you think of how manipulator calibration influences robot programming? Industrial manipulators are usually calibrated for kinematic errors as well as other errors. Can you think of these errors? Think about these questions. We will discuss them during the laboratory. This concludes this introductory session. Questions. Perhaps the most fundamental question one can ask about a robot is, where is it? From the book Modern Robotics by Kevin M. Lynch and Frank C. Park.